Welcome to the Selmo Academy tutorial video series. In this video, we will look at the Continuously Monitored Zones CMZ in machine operation. These zones are critical for safe operation and protection of both operator and machine. CMZs refer to areas in a machine that are continuously monitored by sensors or other monitoring mechanisms. These are often critical components or processes where errors could have serious consequences. Examples include monitoring the temperature of the cutting tool and material in a CNC machine to prevent overheating. CMZs are found at the plant, hardware zone, and sequence levels. This classification determines which level is shut down when a fault occurs. A fault at the plant level, such as loss of compressed air, will cause the entire plant to stop. Errors at the hardware zone level will stop the zone in question, and errors in sequences will stop the corresponding sequence. All errors are logged in the alarm history. The creation and editing of the CMZ is done using an editor that offers several options. There are three types of errors that can occur. 1. Fatal faults. These fatal faults deactivate the automatic mode immediately if a linked variable fulfills the condition. For example, the input signal of a circuit breaker is linked to a variable. As long as this signal is false during operation, the automatic mode remains active. 2. Gate fortress faults. These occur in the event of access violations. Variables can be defined to monitor signals from safety gates, light curtains, or sensors. In the event of a violation, automatic mode is deactivated and the corresponding access violation is displayed on the HMI. 3. Warning faults. These serve as information for the user and do not jeopardize the automatic mode of the installation. They are displayed on the HMI and can be used to indicate upcoming hazards, such as lack of material or decreasing levels. CMZs are an indispensable part of safety and quality control. They ensure smooth operation and protect people and machinery from potential hazards. Stay tuned. In the next video, you will learn more about the PLC code generated from the process model.